Okay, so let's take a look at this question. So you're given a quadratic x squared plus bx plus 25. So what you can see is that b has been left as a variable. And it's asking you, for what values of b will the equation have? And now we have three different scenarios. So what we need to recognize, again, is that if we have two equal real roots, what does that mean about our x-intercepts? Well, two equal real roots is the case where we have one x-intercept. Two distinct roots, meaning we have two real roots, okay? That's two x-intercepts. No real roots, zero x-intercepts. So what's really important for us to do is to associate this with now the discriminant. So we don't need to use the whole entire quadratic formula. We just need to know about the discriminant. So we know when we have one x-intercept, the discriminant is 0. When we have two x-intercepts, the discriminant is greater than 0. When we have no x-intercepts, the discriminant is less than 0. So we've talked about this before, about how in order for a number to go from negative to positive, it has to pass through the value 0. So actually what's really important here is for us to figure out where the discriminant is 0 so that we can figure out where it's greater than 0 and less than 0 very easily. So what I want to do is first I need to evaluate, or I need to come up with an expression for my discriminant. So in this case, when I look at x squared plus bx plus 25 equals 0, I can pretty easily, well, that's a 1, right? Which we normally wouldn't write. Okay, but I can see that my a value is 1, my b value is b, which looks a little weird, but that's okay, and my c value is 25. So what I'm going to do is write my expression for my discriminant as b squared minus 4ac. So the discriminant for this quadratic is b squared minus 100. All right, so let's move forward from there. So when am I going to have two equal real roots? Well, we know that in order to have two equal real roots, we need to have our discriminant equal to 0. So what I'm going to do is take my expression for the discriminant, and then I'm going to set my value of the discriminant equal to 0. I have to be careful here because actually there are two values where my discriminant will actually be 0. So that's when b is plus or minus 10. So for example, okay, so if I know that b is 10, I know that x squared plus 10x plus 25 equals 0 will give me one x-intercept. I also know that x squared minus 10x plus 25 equals 0 will give me one x-intercept, because what we're saying there is that b plus or minus 10 is the b value in my given quadratic. Okay, so what I'd like to do actually is I want to visualize this. So I am going to draw a number line, and this number line represents the b value. So what we know right now is that if b is negative 10, or if b is 10, I know that I have one x-intercept at these two values. Okay, and the reason that's true is because my discriminant is going to equal 0. Okay, so where will this thing have two distinct roots, or two x-intercepts? Well, in our notes from above, we know that that's true when our discriminant is greater than 0. So again, I'm going to start with my expression. I'm going to start with my expression for my discriminant, but then I have to recognize that this thing has to be greater than 0. So actually what I want to work with is b squared minus 100 is greater than 0. Okay, so how do I reason through this? Which values of b will get me something greater than 0? Well, I think I can see that if b is greater than 10, or if b is less than -10, I know that my result will be greater than 0. Another way to write this actually is in interval form notation. Okay, so if I wanted to write this as in interval notation, I could say that b is defined as -∞ to -10, so that's this guy, union 10 to infinity. Notice that I didn't use square brackets there, they're round. Okay, so in other words, maybe I'll do this. Okay, so in other words, all of this represents, in red, represents where b is, or the discriminant is greater than 0. So there are two x-ints. And if I wanted to, I could just pick any values to show that this works. So if I had, for example, x squared plus 11x plus 25 equals 0, I would have two x-intercepts if I use the quadratic formula. Okay, and the last one should be pretty easy because by sort of the last one should be pretty easy because by the process of elimination, we know in order to have 0 x-intercepts, okay, i.e. where the discriminant is less than 0, it's basically the leftover piece, right? So we need to know where b squared minus 100 is less than 0. And what we'll realize is that is for any value of b between -10 and 10. Okay? And that's again an interval notation. So we can write it here on this number line. Okay, and I will put that around here. Okay. All right. So guys, there is homework associated with this lesson, and I would like you to submit that at the due date I have listed for you in Google Classroom.